Actually, I changed my mind. We're going to talk a little bit about it first, so because I want you to understand his video a little bit better when you just kind of watch it cold. So another way to solve this equation, ax squared plus bx plus c equals 0, is we might hope we could factor it. So we could factor out, we could divide out the a or factor out the a. Actually, I'll just divide through by a. This is going to have the same solutions as x squared plus b over a x plus c over a equals 0. Why is that? Why is this solution and this solution, or sorry, this equation and this equation going to have the same solutions?
Well, you're just dividing by a.
Okay.
So.
It's like multiplying a line by a number. It's just going to stretch it. And you're still going to have the same, I guess it's not actually a great analogy, but in this case, the roots are going to stay the same and you're just kind of stretching it out.
Yeah, or even without thinking about the geometry, we could think about just purely the algebra.
Mm-hmm.
If this equation equals 0, and assuming that a is not equal to 0, I can multiply this side and this side by 1 over a, and nothing changes.
Yeah, nothing changes.
And I'm hoping that I can, a different way to solve this would be factoring. So I could say this is x minus the root 1 times, oh, you know what, I think in his video he uses r and s for the roots. X minus s equals 0. Instead I could factor it equaling 0. And so if a product of two things equals 0, what needs to be true?
One or both of them has to be 0.
Yeah, one or both has to be 0 if a product's equal to 0. Now you're studying linear algebra now. This is not true with matrices.
But luckily we're dealing with numbers here.
Funny enough. Do you understand? Okay. So when I look at the two roots here and I multiply this out, I get x squared minus r plus s x plus r times s equals 0. And so I have the product of the roots has to equal c over a. R times s equals c over a. And r plus s equals minus b over a. Okay, where did these equalities come from?
These are just, so when you multiply this out, you know that this has to equal this term, and this has to equal this term.
Okay, where did this minus b over a come from? Can you tell me that? Why isn't it equal to b over a?
Well, you're multiplying by negative r plus s here, so it has to be negative on the positive r plus s has to equal the negative.
Yeah, and so this is the background for what Po-Shen Loh's video is going to be about. And there's just one more little subtle thing that he says that I think you'll understand, but I just want to give you quite a little bit of a preview of it. So if I have two numbers, r and s, and they add up to minus b over a. Okay, so I just have two numbers, and they add to this term, minus b over a.
Yeah.
I want you to tell me, would you be able to tell me, just from this equation, what r and s are, just from this equation alone?
No, I don't think you would.
Okay, give me an example of why not.
Well, there could be,
Like you can
say,
give me
if
a
you have-
concrete example.
like, say b over a was equal to negative 2.
Okay, so that I have the equation r plus s equals 2.
So, then, well, there are multiple pairs of numbers that can add to 2. There's like 1/2 plus 1/2, 1 plus 1, or
Not a half plus a half.
I said 1/2.
Oh,
plus
1.5. Okay, yeah, 1.5 plus a half equals 2, 1 plus 1. Okay, so I can't solve it just from this equation all by itself. So I can't tell you what r and s are. But
Yeah.
so here's my next question for you. Could you tell me what the average of r and s are, even though I don't know what the numbers are? Could you tell me what their average is?
Well, yes.
Okay, how?
Because you know what r and s sum to, and you can just divide that by 2, and that you get the average.
Okay, so the average of r and s equals what?
Negative b over 2a.
Okay, so he's going to talk about that in the video. And so now that we've gone through this background, I think we should watch the video now.
All right.